On question 1, find the point at which the graph y equals 8x squared plus 9x minus 3 has a horizontal tangent line. So the very first thing we want to do on this problem is take the derivative. And we get 16x plus 9. And what you do whenever you're wanting to see where the original graph will have a horizontal tangent, remember the derivative is used to find the slope. And when you want to find the slope at a particular point, when you're given that point, you plug in that x value into the derivative. Well, we're not given a point, we're finding a point. But we are given the slope. We're given the slope of 0 because it says it wants us to find a horizontal tangent line, and a horizontal line has a slope of 0. So what we'll do is we'll set 16x plus 9 equal to 0, and we get x equals negative 9 over 16. Now, this is our x value. When we want to find our y value, we'll just plug in negative 9 over 16 into the original function, and that'll give us our y value. I had people messing up right here when they were squaring that negative 9 over 16. When you square a negative, you get a positive. So that came out to be a positive 81 over 256. And we simplify this down, and I get negative 177 over 32. Find the derivative of this function. Okay, so let's read it. Y equals x cubed times e to the x. So you heard me say that times x cubed times e to the x. We have a function times a function. So we're going to use the product rule. See, this is this function times this function. So f is x cubed, and g of x is e to the x. So our first function, x cubed, second function, e to the x. The derivative of that first function is 3x squared. The derivative of the second function, well, the derivative of e to the x is e to the x. So let's plug this in. Y prime equals x cubed times e to the x plus e to the x, times 3x squared. And a lot of you left it like this. I'll take it like that, but I'd rather you pull out that GCF to get a final answer of, let's see, there's a x squared in both, or there's an x in both, and the lowest power you have is x squared. And then both have an e to the x, so you could be left with x plus 3. Find the equation of the tangent line to the function x squared minus 9 at the point 5, 16. So what we want to do, we're actually going to end up using this formula right here. This is called the point slope formula. In order to use the point slope formula, you got to have a point and a slope. Well, I can already plug in my point. Let's let's see. I can already plug in my point right there. I just don't have the slope. And that slope is going to be given to us by the derivative and plugging x into that derivative. So in this case, the slope is going to be f prime of 5. But let's find f prime x first. It's going to be 2x. And so f prime of 5 is 2 times 5, which is 10. Distribute that 10. And we're going to add 16 to both sides for a final answer of 10x minus 34. You can see right here my directions aren't really that great. I said find the derivative on questions 4 through 8. On question 8, though, I have a more specific set of directions, but anyway, you're still finding the derivative, I guess. On question number 4, you have y equals 4x minus 3 divided by 6x plus 1. And so it's really important for me to read that. 4x minus 3 divided by 6x plus 1. Divided by, that tells me I'm using the quotient rule, which we know to be, let's see, denominator, derivative of the numerator, numerator, derivative of the denominator, all divided by the denominator squared. Okay, so the denominator is 6x plus 1. Let's go ahead and do the derivative of that, which is 6. And the numerator is 4x minus 3. So its derivative is 4. And let's just go ahead and plug in y, or go ahead and find the derivative. So y prime is, let's see, 6x plus 1, derivative of the numerator, which is 4, minus the numerator, 4x minus 3, times the derivative of the denominator, all over the denominator squared. So cleaning this up, 24x plus 4, I just distributed that 4. I'm going to distribute a 6 and a negative sign at the same time. So let's see, that's going to end up being a negative 24x and a positive 18 all over 6x plus 1 squared. And we end up getting 22 over 6x plus 1 squared. Okay, right here we have a product rule. 3x squared plus 7 times 5x plus 5 plus 6 over x. So our, let's see, and I'm just going to, I'll think of this as 6x to the negative 1. I think that'll make me happier. So the first function is 3x squared plus 7, and its derivative is 6x. And the second function is 5x plus 5 plus 6x to the negative 1, and its derivative is 5. Okay, the derivative of 5x is 5. The derivative of the 5 that's right here is 0, so I'm not going to write down plus 0. And then the derivative of 6x to the negative 1 is negative 6x to the negative 2. And just remember, our product rule is first derivative of second plus second derivative of first. So let's go ahead and plug this in. Y prime first, derivative of second, second, derivative of first. And let's perform this distribution. Right here we're going to have a FOIL method, okay? So I'm going to say 3x squared times 5 3x squared times negative 6x to the negative 2. That's going to be negative 18, and the x's cancel because you're saying x squared, so 2, and then x to the negative 2. Negative 2, you're adding those together, you get x to the 0 power, which is just 1. Okay, now I'm going to say 7 times 5, and then 7 times negative 6x to the negative 2 is negative 42x to the negative 2. Six x times 5x is 30x squared. 6x times 5 is 30x. And then 6x times 6x to the negative 1, we get 36, and the x goes away because of the negative 1 plus a positive 1 is a 0 power. And y'all, I'm sorry, I wrote right here, that was 15x squared, and for some reason I wrote a fifth power. Let's see, okay. So 15x squared and 30x squared, that gives us 45x squared. Then we got a 30x. And then we got negative 18 and 35 and 36. Combining those like terms, that's a positive 53. And on the end, we got that 42, negative 42x to the negative 2, which looks better as 42 over x squared. Right here, we got a quotient rule. Remember that quotient rule is denominator, derivative of the numerator, numerator, derivative of the denominator, all over denominator squared. And the denominator in this case is 8w. The derivative of that is 8. The numerator is 5e to the w. And the derivative of that numerator, okay, so that constant 5 stays there, and the derivative of e to the w is e to the w. So let's plug in. Denominator derivative of the numerator, derivative of the denominator, all over the denominator squared. Let's pull out a GCF. There's a GCF of 5 and 8, so that's 40. GCF of also of e to the w in the numerator. And you're left with w minus 1. Because, see, I pulled out, let's see, let me change that arrow. I pulled out an 8 and a 5 and an e to the w. So I was left with this w right here. And then again, I pulled out a 5, an 8, and an e to the w. So you're left with 1. You can leave it like this. But you could also think of that denominator as 64 w squared. So you square the 8, you square the w. And 40 over 64 simplifies into 5 over 8. Got another quotient rule. Y equals 2x to the 5th plus 8 divided by x cubed. So do remember that quotient rule is denominator derivative of the numerator minus numerator derivative of the denominator all over the denominator squared. Again, quotient rule because we said 2x to the 5th plus 8 divided by. Quotient means divide. So this is the division rule. Let's go ahead and label some things out. Denominator is x cubed. Derivative of the denominator is 3x squared. Numerator is 2x to the 5th plus 8. Derivative of that numerator is 10x to the 4th. So plugging it in. Denominator, derivative of the numerator. Numerator, derivative of the denominator. All over the denominator squared. Let's do some multiplication. This is going to be 10x to the 3 and 4 is 7. I'm going to distribute the 3x squared and that negative sign at the same time. So that's going to be a negative 6x to the power of 7 as well, because 5 and 2 add to give you 7. And that's going to be a negative 24x squared all over, we'll just call this x to the 6th power. When you have a power to a power, you multiply. Let's see. 4x to the 7th. Minus 24x squared. X to the 6th in the bottom still. Let's pull out GCF in the top. There's a GCF of 4. There's a GCF of x squared. You're left with x to the 5th minus 6 this x squared and this x to the 6th, let's just say both of these x's right here cancel with 2 of these and leave us with 4 times x to the 5th minus 6 all over x to the 4th. Now right here, it says use the limit definition to calculate the derivative of this function. Now, I'm going to just tell you really quickly and really easily, the derivative of this function, we know by the power rule, is negative 4x, right? But that's not the way I want you to do it. In fact, if that's what you write down on your paper and that's all I see, that's no credit for that problem. I need to see that you're looking to find this derivative by evaluating the limit as h approaches 0 of the difference quotient. And how are you supposed to know that this is the way I want you to do it on this problem? Well, it says use the limit definition. Okay, so limit. Before I evaluate the limit, I am going to find out what f of x plus h is. And so if we're dealing with a negative 2x squared, then that's negative 2 times x plus h squared. We know x plus h squared is, it's x plus h times x plus h, but once you fold that out, you get x squared plus 2xh plus h squared, which is negative 2x squared minus 4xh minus 2h squared. So evaluating the limit. F of x plus h. Minus f of x all over h. So our x squareds cancel. We'll factor out a h. We have the factor of h that cancels. Okay, so now if you plug in 0 for h, we get 4x, negative 4x. That's our derivative.